Alright, so we're back, and this is part 2 of rate laws, and we're going to look at the homework problems, because I'm assuming these are going to probably be on the test, like something very similar, and look how to figure them out. So right here are the 3 equations that we're going to use to solve question 2, the different parts. I found out how to find K and how to find the concentration of whatever they're asking us to find by manipulating the rate law here algebraically. So just like dividing to isolate K if that's what you need to find and stuff like that. Pretty simple, but if you don't want to go through all the work, the equations you need are literally right here. So let's get to business. So let me switch to yellow. Okay, so question 2 is saying, suppose the reaction D decomposes into products and is in first order. Part A, write the rate equation. So we know that the basic setup for any rate law is going to be rate equals K to the concentration of whatever you're asking to the order / power of whatever you're need or asking. So that means for question 2, rate, don't know what K is, D to the power of 1, because it's in first order. That's literally part A. Simple. Easy peasy. Part B. If the rate is 9.2 times 10 to the negative 3, so she gives you the rate, when the concentration of D is 0.56 m, so she gives you the concentration, what is the value of the rate constant K? So your teacher's asking you to find K. And you're going to use this equation right here to do so. So it's rate divided by the concentration of whatever element or compound you have the concentration of. So we know the rate is 9.2 times 10 to the negative 3 with the weird unit because they give it to us. And you divide that, oh my gosh. You divide that by the concentration of D, which is 0.56 m. She also gives that to us. Perfect. So type that in your calculator. I'll give you a second to do so. And you should get, if your calculator is already in the scientific notation setting, you should get 1.64 times 10 to the negative 2. And the unit for K is min to the negative 1. And that is because when you divide these two, the molarity unit cancels out, which leaves you with this guy for the unit. So that's how you solve for K. Since K is a constant, you will need to use it for the rest of the problems. It's not going to change. The molarity and the rate might change throughout the rate laws, like, by the order, if you add a more concentrated solution or something. But since this is a constant, it's never going to change. So you get to use it for the majority of your problems for part C and D. So, part C. What would be the rate when D is 1.4 m? So she's asking you to find the rate. And whenever you solve these, it's really nice to write what you need to find. So you need to find rate. You can just put rate equals question mark. And it's also nice to write what you already have. You already have K because we literally just solved for it right here. And you already have the molarity of D because she gives it to you in the problem. So you need to find rate. In order to do that, you just use I'm going to go back to black. You just use a regular rate law equation. So rate equals k, which is 1.64 times 10 to the negative 2, because we literally just found that out, times the molarity of D, which is 1.4 m. And then you multiply those by each other. Give you a second to type in your calculator. And you should get, if your calculator is in scientific notation, setting already, 2.30 times 10 to the negative 2. And if you remember from the first example, the rate unit is m times min to the negative 1. So that's the rate if the molarity was 1.4. Sweet. Now on to part D. At what concentration D will the rate be 6.6 times negative 4? So you're going to find the concentration of D now, and that's when you use this third equation right here. So let's write out what we already know, / what we already have, and what we're already looking for. So we're looking for the concentration of D. And we already know the constant K. It's the same thing as what we solved for, because it doesn't change, it's a constant. So that's kind of easy to remember that. And she gives you the rate. And the equation you're going to use is, let's see, this. So my bad. Just skip through that part, because now it's not working. There we go. So concentration of D equals rate divided by K. And we know the rate because she gave it to us. 6.6 times 10 to the negative 4. Weird unit. Divided by K. We already solved for that, so we know it's 1.64 times 10 to the negative 2. Other weird unit. Type that in your calculator. It should be able to solve pretty simply if you type it all in scientific notation and you already have it on the scientific notation setting. Molarities are usually not small as numbers as rates and K constants, so you're just going to probably get a decimal kind of like this, which is the answer. So if you don't see it come out in scientific notation, don't be too weird. And that is the molarity of D given with a certain rate. So that is how you solve these problems. Pretty quick and easy. You know, practicing just will make you even more better at it. I won't go through these because now that you kind of know how to do it, I want you just to go through this on yourself, on your own. But it's important to note this is second order. So you're going to go through the same steps that I just showed you, but it's really important to remember that since that's supposed to be a star, oops, since it's in second order, that the equations are a little bit different. Always remember to square the concentration because it's in second order. So now it's at the exponent 1. You have to remember to square it. Same thing here. When you're plugging it in here, always remember to square it. Only the concentration. But when you're finding, let me erase those. And when you're finding the concentration, since it's in second order, you would have to square root this and square root the answer you get. And I do little square roots there so you don't forget. Just because it's by the power of 2 and you'd have to square root to get the inverse. So yeah, that is how you solve basic rate law problems.